So let us connect. So this is our primary node, and let me show you the data which I have imported here. So I'll go to the GitHub database. I'll say show collections, and I'll see the count of records here. So these are basically the 1.9 million records which I was talking about, and they are imported into this collection. So let us execute some queries to see what the data like in this database looks like. Let us say we want to find all the commits by a user. So I mean, generally whenever there is such a data and we want to access on a field, we generally create indexes. So it came up. So that was, I mean, did not take much time. So what we see is there are like approximately 5 records, and it has printed all of them on the console. Let us try to run another query. Let us count the number of events where the repository name was edx platform. Let us see the number of records. In MongoDB, if we want to do any group level aggregations, then we will have to use the aggregation framework. Aggregation framework is similar to pipeline concept in Unix. Documents from a collection enter a multi-stage pipeline that transforms the document into an aggregated result. Pipeline stages, these help in filtering the documents like queries do, and then document transformations can also be done, and the output resulting can also be stored into a collection, so that if the similar transformation is required for future, we can just refer the collection. So let us look at some of the stages. The first stage is a project stage. In this stage, what we do is we try to select the fields from each row of a collection, and we try to see uh, basically we try to select the fields which we think will help us get the desired aggregated output which we are looking for. The second stage is a match stage, which wherein we basically filter the documents. Like let's say the age is in between some criteria, or the person belongs to a particular state uh, in the country, something like that. Then another stage is a group stage. Group is basically like on the filter documents you want to group them together. Like let's say grouping of all the California uh, citizens, or all the people residing in California, and trying to find a average salary for people staying in California. So we use some kind of a group. So sort stage is basically to sort the resulting data. We can say give me the top 5, in which case we will sort descending fashion. We can say the least, in that case we'll try to sort it on the ascending fashion. Limit is basically used to reduce the size of the result set, and then the out stage is basically if we want to store the output of this aggregation into a collection. So let us try to find answer to our first question: day and hour with maximum number of commits. So let us try to execute this query on the Mongo interactive shell, and see the output. So this is the query, and let us go on the shell and let us connect back. Let us run this query. So let us go to the next question which we wanted to get answered. Login having maximum number of associated events. For this, let us try to execute the query. In this case, we are only using the group because we are just interested in the like we want to group against the login credentials of a user. So we are directly calling a group stage here. I could have ideally added a project stage as well in front of it, but I just wanted to show that I mean different stages. I mean we can have. I mean there are different ways of writing the same query. Ideally, adding a project stage would have been a more optimal one. So in this case, when we run this, we see that Google Code Exporter comes up as one of the logins uh, having the maximum count. I think since a lot of projects are moving from the Google Code, the open platform which Google had for storing the projects, to GitHub. So this is one of the accounts which GitHub internally uses to move that code here. So let us see which user, let us see the commits, like the login having maximum number of commits. For that, this is a query. In this, what we basically do is we try to do a match first, where the event is commit comment event, and then we do grouping on the again the login, and we try to find the user with maximum number of commit events. So this seems to be like a real person, not a tool. I mean, yeah, sorry. So now let's try to find 10 most active projects. Basically the projects having maximum number of events associated to it. For this, this is the query, and over here what we are doing is we are projecting only the specific project name, and then we try to group on the project name and sum up all the events, and we are sorting in a descending fashion because we want to take the top few records, and the limit we are saying 10, that we are only interested in getting the first 10, the best, the 10 projects with most number of events associated to it. Okay, so seems like commit span is one of the projects with maximum number of events associated to it. Let's move back to the presentation. So then there was one, we wanted to find out 5 projects with maximum number of folks event. So let us try to execute the query for that. So in this case, what we are doing over here is we have added a match stage, and we are saying like match only records having type as folks event, and then we group on the repository name, and we are just trying to sort it in descending fashion and get only the topmost 5 records. And one of the last and one of the most important uh, aspects of the aggregation framework in MongoDB, generating trends per repository. So over here, what we really want to do is we want to see the events per repository per day, and we want to store it in a collection called daily. So this is the query for it. So what we are over here doing is we are selecting only the fields type and the repository name and the date. We are only concerned in the date part of it and not the hour part. So since date being a string, we are just taking the first 10 characters of it. We are grouping it. If you look at, we are grouping it based on the date and the repository. Basically, we want one record per date and per repository. We are summing them up, and over here we are using the $out stage, and we are saying that output this information into the daily collection. So let us execute it. I think it is going to take some time since there are like quite a few projects active on GitHub during this time frame. So in the meantime, what we can do is, I'll quickly go to the last slide, basically scaling MongoDB sharding. So what we basically had been using was a replica set. Replica set, still it means that there is one primary node, one secondary node, and one arbiter. And since it says one primary wherein all the writes go, so we know that no matter however big machine we have, a single machine can only do that much. So what is the way to achieve scalability for MongoDB? So over here what we do is we basically add more and more number of replica sets to the cluster. So basically there will be more number of primaries to write the data to. When we decide to use sharding, there are two additional components which get added to the MongoDB setup. One is a config servers. Config servers basically store the chunk metadata, that is what information is stored in which shard. And then there is also a router component, MongoS, which basically uh, interacts with the config servers and the shards. The applications, they always talk directly to MongoS. They never directly talk to the replica sets, and MongoS redirects all the reads and writes from the application to the corresponding replica set. Additionally, there is one constraint over here. Every document which we want to insert needs to have a shard key. Shard key is immutable. Uh, Shard key is basically used to identify uh, each record. Basically, the config servers maintain the chunk information based on the shard key. So let us see if our import is done. Okay, so our import is done. Let us see if a collection called daily is there. Yes, there is a collection called daily. Let us see what data is there in this collection. What I wanted to show using this was that we can use the aggregation framework to generate and store trends for every repository. The same principle can also be used in several real life applications as well. Like let's say we want to see how is the viewership of a TV advertisement, or let's say a YouTube video. So basically YouTube might be collecting similar events, and they might be running some kind of an aggregation on them, which basically says like every day these many videos, I mean these many users viewed this video, and they might try to extract some additional data, or they might want to sell that video and for some advertising business. So that was my project submission. Thank you very much.